we got AMD's RX 590 in about 24 hours before embargo lift, and we're not gonna pull another all-nighter twice in 1 week to review the card. So what we're gonna do today is a teardown. Gotta put some thermocouples on it here for the review. And the card we're working with for this teardown is the XFX RX 590 Fatboy, which honestly isn't even all that fat. So marketing making up for substance, I guess, or they've named it after the nuke. But either way, we're gonna take it apart and see what the new RX 590 looks like underneath on the XFX Fatboy card. Before that, this video is brought to you by the EVGA Supernova G3 power supplies. Unlike other power supplies on the market that get easily tangled, the EVGA G3 power supplies are modular and use sleeved cables, so the PCIe connectors won't get caught in your hair when building a system. The Supernova comes in several options, including popular 650 watt and 750 watt units, and is fully modular with a noise-focused fan profile. Learn more at the link in the description below. Very basics first, the RX 590, we're gonna review it shortly, but the card, the GPU, the RX 590 is an RX 580, which is an RX 480. It's just been pre-overclocked on the RX 580, which was a pre-overclocked RX 480. So it is a pre-overclocked RX 480. The voltage required for a given frequency is a bit lower on the 590, so that absolutely has some value, and the price proposition may play out differently. We'll see how it works in the review, but again, we need to start with taking it apart because I need to put thermocouples on this. So we're gonna work with this XFX card primarily. It is honestly, despite its name, not all that fat. So this is a little more than 2 slots. It's about 50 millimeters. The EVGA card only has maybe 4 millimeters on the XFX card, but the EVGA card has a significantly fatter heatsink. So XFX's entire fatness on the Fatboy is consumed by the distance between the backplate and the PCB, which doesn't count, and the distance between the shroud and the cooler, which doesn't count. So the actual cooler substance is significantly less than something like this. That said, there's a 2080 Ti. It produces a lot more heat, and it's $1,200, so it's not really a fair comparison. The point, though, is to say that the name Fatboy it's just kind of dumb. Okay, so we got that over with. Let's move on to taking the card apart. Okay, so we're gonna start this teardown. We're using just an iFixit bit kit, and they're not a current advertiser, but we like to plug the kit that we use. It's a ProTech toolkit if you wanna pick it up. And we're just gonna start by taking out the screws for the heatsink itself and see if removing the heatsink is possible with only removing 3 screws. First problem I have, that sticker says void if removed. That is not enforceable in the United States. You can't do that here. So XFX, there's what I think of your warranty. Seriously, this is bad, and this is a problem. Void if removed stickers on screws are a way to try and intimidate end users out of repairing and maintaining their own devices, which we are strongly opposed to that kind of action, but they probably wouldn't enforce it anyway. And good luck telling if most people took it apart to begin with. You just say, I don't know anything about computers. So this didn't immediately fall apart. Sometimes it's only 4 screws holding the heatsink in. So we're gonna take the rest of them out this time. Oh, there it is. They're hiding. Okay, so 2 more screws that are hiding here. So we're gonna take out that one, and then that one, and now the XFX RX 590 Fatboy should have its backplate boy or shroud boy removable. And the backplate is not, here you go. So the backplate, you look down the middle here, there's the screw going through for that, and those screws are on the top side. So we gotta take those out if we wanna remove the backplate, but typically something else should come off first. There it goes. Cable. Okay, so warning number 1 on this card. It would be really easy to rip this entire connector off this board the way they've mounted this. So if you pull on the cable, the connector, the housing on the board side, will start separating from the pins that it's on, and it'll pull up with the cable if you aren't careful. So if disassembling this card, probably just leave it connected if you're just redoing the paste, but otherwise be really careful with it. I'm gonna take some time to get it off properly. Otherwise, it will rip things out of the board. I'm so tempted to just leave it alone. I see the pin. There's a secret pin. There's like a little plastic button in there under the housing that's hooking into the bottom of the housing. I don't know if it's a manufacturing defect or if it's an intentional way to try and lock people from removing the fan. But I'm just grinding it off with a screwdriver until there's no more plastic bump there. The right side is already free. The left side needs a little more work. There it goes. All right. Okay. I have not had that problem before. I've taken apart dozens of video cards over the last few months. Actually, that's not true. I've taken apart dozens of video cards in the last 48 hours. And this one, so it's pretty standard fan header. This is not unique, but it just had like a little plastic bump that was stuck, and it's supposed to be a hook to prevent it from coming out of the housing. There's still, I left part of one on there, this one down here, you probably can't really see it, but one of them had like bonded with the plastic housing, so I don't know if that's a manufacturing defect or what was going on, but I just kind of chiseled at it until it was unstuck and I could separate them. So, all right, we'll look at the cooler in a second. This is the card, and for the PCB, I'll remind you it's an RX 580, which is a 480. So this isn't really anything tremendous and new that you haven't seen before, but it is still new silicon, and that's because it's a new fabrication process for this piece. So nothing on the die. AMD typically doesn't put text on the die, unlike NVIDIA. You can still see, it's got their tension plate, everything about it's pretty much the same. The die size, I guess we'll go ahead and measure that to the best of our abilities. So external die package, which is not the exact same as die size, roughly 17.5 by roughly 14. And that's an external measurement, but you get the idea. So there's die size. Memory, same as before. So this memory is Micron. It has 2, 4, 6, 8 gigabytes of it, as you would expect on an RX 580 or 90 in this case. They are not going to be making a 4 gigabyte version to my knowledge, so this should be the only version there is. And then we also need to take apart take the backplate off. So let's get that off of there. That's going to be done by removing the screws on now the front side where the PCB is. You can also see a multi-BIOS switch. We'll go over that in a second. And I'm going to track the screws on the mod mat over here. So store.gamersnexus.net if you want to pick up a mod mat like the work service that I am on right now. And the next round will come in, we'll be shipping out in the first half of December. So if you're in the US, you definitely have a chance of getting one before the holidays if you order soon. And then we'll be sold out again probably shortly after that. So not too many screws here. We've got, for the back plate, 1, 2, 3, 4, 5, and then one here for the I/O. So it puts us up to 7 screws underneath the cooler. And then we have 1, 2, 3, 4, 5, 6 screws for the back side of the card that were already removed. So really not that many, which is good. You want to do more with less with screws. And those were not necessary to remove the back plate, but we're going to get rid of the I/O potentially in a minute. So okay, back plate. It's a back plate. It's made out of metal. It's aluminum back plate and connects. Actually, does not connect to the card anywhere. So it is utterly pointless. This is not a functional object. It's got some like just a protective coating there, so there's no direct contact shorts between the board components and the back plate, but no thermal pads connecting anything, so that is non-functional. It does not do anything. In fact, it may trap some radiative heat that radiates off the backside. Now, does that matter? No, not really. But there is no reason this can't be functional other than they didn't want to spend a couple of pennies, literally pennies, on a thermal pad between like the inductor line and the backplate. That would pull some heat off of the card. Again, not going to affect the core temperatures, but also if you're going to go through the effort of making a big metal backplate, at least go through the effort of buying someone else's thermal pad and sticking it on there. So that's the backplate. The front side for the VRM, it is using some familiar design. Let's see, looks like a 6+1. We'll confirm with BuildZoid, and then it's an IR, so International Rectifier 35217, which is actually a really common controller, and you can see that piece right there. So that's the IR 35217. This is on really most motherboards right now, and on lots of video cards as well. So that is a common component. We've spoken about it a lot. The MOSFETs are also IR, and those are 3578. Let me just double check. Yes, 3578 is that component. And those are used for both the memory and the core VRM. As for the rest of the board, there's a VBIOS switch up here. So that's probably your typical performance mode and quiet mode, but we'll check marketing language on that. And then just as a reference for everybody, it is in the front position default. So that is how we will test it, but we'll double check what the two switches are. Okay, so that's the PCB. Here's the cooler. For the cooler, you've got thermal pads for contacting the memory. We're gonna put a thermocouple on one of those memory modules, probably the hottest one, which would most likely be this one. So we typically try to put thermocouples on the hottest modules. This is likely to be the hottest because regardless of where the fans are positioned, it is next to two of the hottest parts. So you've got the MOSFET and the inductors right there. There's a line of capacitors between them, but it's still going to be dealing with a lot of radiative heat. And then you have to remember these are all on like the same power planes. It's on the same PCB. PCB is made of copper and fiberglass. So naturally you're going to conduct heat from everywhere on the board, especially if things are adjacent. So we'll probably test that module first. The cooler, so the red line of thermal pads is going on the MOSFETs, which is apparent from the indentation in them. The gap here is over the inductors, so there's no direct contact between the inductors or the capacitors, but that's fine. They're hot, but if you hit it with airflow, which will happen, then that is sufficient. So we have no problems with leaving inductors without a thermal pad as long as there's airflow. And there is. This fan is right over them. It's going to go through fins. They're straight fins. They're not L-shaped fins. So that air will go straight through, hit the inductors, and they'll be just fine. They don't need direct contact. The memory module we're likely testing has that pad. The other stray module on the bottom of the card's got that one. And now that you're oriented with this at the bottom of the card, you can see the heat pipe orientation. And that's got a copper cold plate to the bottom that is soldered to the heat pipes. And then the heat pipes do not appear to be soldered together between them. Oh, no, there is some solder in there. So some solder in between the heat pipes, solder to hold the cold plate to the heat pipes. And then there's a nickel-plated plate, and this is or aluminum. It might be aluminum. Not 100% sure, actually. That's a mounting plate. I don't know what that is. Not clear on the material for this shiny material. Not clear on that. Let's just rule out that it's steel, though. No, okay, it's not aluminum. So that is not aluminum. Aluminum is not magnetic, as you can see here, because that's an aluminum set of heat. That's aluminum heatsink, and then aluminum here, copper here. So that looks to be a stainless steel, which is actually a terrible conductor of heat. Depending on what kind of stainless steel they're using, it's like 70 watts per meter Kelvin. Whereas if you're talking aluminum, you're at 205 watts per meter Kelvin at 25C. Copper is, if it's good copper, is like 405 watts per meter Kelvin at 25C. Depends on the grade of material, of course. There's bad copper, there's bad aluminum, and there's good stainless steel or good steel. But this is typically not a great surface. Also, a shiny surface is bad at dealing with heat. You have reflective heat that you also have concerns with, depending on what kind of components are being cooled. So, not a great solution for the memory. We'll test it and we'll see how it does in testing. But it's kind of odd. This thing is screwed in. Let's just take that out and just see what happens. Like, why is this screwed in? Probably just to secure it, because it's not manufactured as part of the aluminum plate under it. Then the question is, why didn't they manufacture the aluminum plate under it to meet the memory modules instead of requiring an additional plate to sit in between them? Okay, wow, interesting. That's so weird. So they have two perfectly good materials here for conducting heat. One is copper heat pipes, which can't get much better than, other than being not direct touch contact. Not direct contact copper is suboptimal, but still good, especially with like thermal paste in between the gaps, or a thermal pad would be potentially okay with enough mounting pressure. Then you have aluminum. It's kind of messy aluminum, but it's aluminum nonetheless, clearly. And the only reason really not to just do a, well, let's see. Nope, that's not a reason. Okay, so, why does this exist? Spacing, mounting pressure, something along those lines. It might be a mounting pressure thing. Maybe they're trying to avoid crushing the die of the memory or of the GPU if there's not this dense material in between the plate and the silicon. I don't know. I don't know if it's a mounting pressure concern or if it's a contact distance concern, because my inclination here is if I take this thing off, assuming it doesn't like crack the die or something when I remount the cooler, and I shouldn't suspect it would, although the screws would have to be tightened a different mount. But if I take this thing off, my inclination is that putting a sufficiently thick thermal pad here that would account for the loss of this steel plate, or probably steel anyway, and also add the same surface area or the same thickness as that pad, I would think that this direct contact with the memory would be superior, but part of the memory modules would be over this gap right here. So you've got that gap in there. There wouldn't be any contact there. There wouldn't be any contact there. So that's a bit worse in that regard. But really, this whole thing should just be widened and flattened. Why it was built this way, not sure what their design decisions were, but this is an inefficient use of metal, because they've got two perfectly good conductors here. It's just not complete, so you can't directly contact in a way that would make sense, and perhaps that's why they went with the plate. Now, it doesn't matter. Well, no, the memory's probably still going to be in spec, so in that regard, it'll work. It's just that whenever you see sort of waste by way of poor design or poorly thought out design like this cooler solution, it's really, you want the best product you can get for your money. And this is a poor design choice, but one that we can test, and we will test to see if our approach would be better. I mean, even putting a thermal pad here might even be better, even though you've got less surface area. We've seen it in the past where it's sometimes sufficient or even decent. So that's the bottom end of the cooler. And then the top, they've got a bit of the gigabyte design approach, which is not it's not a great thing. So screws here on a bar holding aluminum bar, I believe, yes. Likely aluminum bar that doesn't do anything. It's not a heat sink. It just holds everything to the shroud. That's on both sides. They've got 4 screws for that. So we don't need to take these 4 screws out. There's really no point, but you get heat pipes running through over the area on the right half of the board, and that's really just so that they can run through where the fans are pushing air. It's not to connect with anything on the board because there's nothing hot on the board in that area. So we're not going to take the shroud off because there's no point. It's just more visibility to the cooler, and that's really it. I mean, that's the RX 590 by XFX, the Fatboy, and Backplate doesn't have any functional purpose. They might say it's structural. It's not. Doesn't do anything for thermals in a positive fashion. Probably not anything really exceptionally negative either. This is a weird, inefficient approach to design, and the cooler otherwise seems pretty standard. So there's your RX 590. Slightly different configuration in that it's lower voltage per given clock. It's higher clocks natively out of the box. This is a partner-only launch. There will not be RX 590s from AMD, so there are no reference cards for this one. There you have it then, the RX 590 Fatboy. Maybe they'll make a slim edition later. And the 590 here is really what we need to look at, not necessarily just the cooler. So the 590 will be testing shortly. Like I said, I had to disassemble it, get the probes on it for thermal testing, and there's clearly a lot of things we can do in addition to normal thermal tests here. So might play around with that. Not sure if it'll go in the initial review or later, but we'll be working on benchmarking the 590 shortly. It is AMD's re-refreshed RX 480, and the re-refresh, no, yes, this is the re-refresh. The previous one was the refresh. I think that's accurate. The RX 580 actually did pretty decently. It's held on pretty well too in value proposition. So the 590 has a place in the market. We'll see how it does though. Just to be clear, so I was very critical of the cooler design here. It doesn't mean the card's bad, doesn't mean the cooler's bad. It just means they could have made it better. But we'll be testing it to validate those statements. And by the time you see this video, likely a lot of those tests will have been done. So check back shortly. Make sure you're subscribed if you're not, so you can catch the RX 590 review. And go to store.gamersnexus.net to pick up a mod mat like the one I was working on here. And you can also go to patreon.com/gamersnexus to help there too. Thank you for watching. I'll see you all next time. Can you see me?